Lesson 6.2. Our objective is to solve a system of equations by using the substitution method. Guidelines for solving a linear system by using the substitution method. Number 1. Solve one of the equations for one of its variables. Number 2. Substitute the expression from step 1 into the other equation and solve for the other variable. Step 3. Substitute the value found in step 2 into the revised equation found in step 1 and solve. Step 4. Check the solution in each of the original equations. Okay, in the previous lesson, you learned how to solve a system of equations by graphing. In this lesson, we're going to learn how to solve the system by using the substitution method. First equation, the first system that I have is y equals a negative 5x minus 8. The second equation is 8x plus 2y equals a negative 16. Now we have some steps that we're going to follow, and I'm going to write down each step. We're going through each step. For my step 1, I'm putting S1. That stands for step 1. Step 1 says to solve one of the equations for one of its variables. With this system that we're solving, it is really an ideal situation because the very first equation is already solved for one of its variables. It's already solved for y. So I'm going to take this first equation and it becomes my step 1. It's already done for me. So step 1, we're going to use y equals a negative 5x minus 8. Okay? Now for my step 2, going to call that S2, step 2. Step 2 says substitute the expression from step 1 into the other equation and solve for the other variable. Well, the other equation that I have is 8x plus 2y equals a negative 16. Now, in step 1, we have y equals this negative 5x minus 8. Well, since now I know what y is equal to, I'm going to take that expression and replace it for y in the second equation. So it now becomes 8x plus 2. Now when I get to the y, I'm not going to write this y. I'm going to put negative 5x minus 8 and equals 16, negative 16. Okay? All I did, I made my substitution here. I plugged in negative 5x minus 8 where the y value was. Okay? Now I just need to solve. I'll bring down my 8x. I can distribute the 2. 2 times negative 5x gives me a negative 10x. And then 2 times negative 8 gives me negative 16. And I'll bring down everything else. I have like terms here. So 8x minus 10x gives me a negative 2x. Then minus 16 equals a negative 16. I'm solving for x, so I'll add 16 to both sides. Now on the left, I'll end up with x is equal to negative 2x is equal to 0 on the right. Now clearly I see what the answer is. X is just going to be 0. Okay? Now that I have x is equal to 0, step 3 tells me to substitute the value found in step 2 into your revised equation. Well, this is the solution that I got in step 2. Now I want to take the value that I found in step 2 and substitute that into the equation from step 1. So this becomes, for step 3, the equation from step 1 was y is equal to a negative 5x minus 8. Okay? Now that I know x is equal to 0, I'm going to substitute that in for my x value. That gives me y equals negative 5 times 0 minus 8. So this gives me y is equal to negative 8. Okay? So now I have my solution. My x value is 0 and my y value is negative 8. Our next system, we have the equations negative 4x plus 3y equals negative 9 and x plus 5y equals 8. And our step 1 says to solve one of the equations for one of its variables. Well, in the first example that we did together, the step 1 was done for us. One of the variables was already solved. One of the equations was already solved for one of the variables. However, this time we don't have that. But this time I'm going to focus in on the second equation. And what I'm looking at the x variable. I'm looking at the x variable because it does not have a number in front of it. The Lie coefficient is 1, and it's understood there's a 1 there. We don't write it. So what I'm going to do, I'm going to take the second equation, which is x plus 5y equals 8, and I'm going to solve it for x. Once again, the reason that I'm solving for x is because it doesn't have a number in front of it. So I subtract 5y from both sides. That leaves me with x is equal to negative 5y plus 8. Okay? Now for step 2. Step 2 says to take the other equation. The other equation is negative 4x plus 3y equals negative 9. Now, I want to take the expression that I have from step 1. In step 1, I came up with x is equal to this negative 5y plus 8. I'm going to take that and I'm going to substitute it in for the x value in my other equation. So that's going to give me a negative 4. Now when I get to the x, I don't put x. I replace it with this negative 5y plus 8. And I write the remaining part of the equation. Now I can solve this equation for y. You'll notice that I only have y variables here. If at this point you still have 2 variables, go back and check yourself. You've done something wrong. So negative 4 times negative 5 gives me a positive 20y. And negative 4 times a positive 8 gives me a negative 32. Then I bring down what's remaining. Now here I can combine like terms. I have a 20y and a 3y, which gives me 23y. Bring down everything else. I'll add 32 to both sides. All I'm doing from this point is I'm solving for y. This leaves me with 23y is equal to 23. I'll divide both sides by 23. That leaves me with y is equal to 1. Okay, now that's my step 2. Now for step 3, it says go back to step 1. So now I need to go back to step 1. I came up with the equation x is equal to a negative 5. X is equal to a negative 5y plus 8. So I'm going to use that equation now. X equals a negative 5y plus 8. And it tells me to take the value that I found in step 2. In step 2, I came up with y is equal to 1. And I'll substitute that into my step 3. So that leaves me with x equals a negative 5 times 1 plus 8. All I did, I replaced the y value with what I found it to be in step 2. Okay? Step 2, I came up with y is equal to 1. I just made that substitution. So now I'll solve this for x. This gives me x equals negative 5 times 1 is negative 5 plus 8. And negative 5 plus 8 is 3. So now I know that x is equal to 3. Okay? So for my solution, I found my x value and my y value. Now remember, the solution is actually an ordered pair. So when I write my solution, I have to put the x value first, and I'll put the y value second. The 3 represents the x value, the 1 represents the y value. So my solution for this system is just 3, 1. Okay, for the next system, I have 5x plus y is equal to negative 19, and negative 7x plus 3y equals 9. Well, for step one, remember step one says that you want to solve one of the equations for one of the variables. Now, keep in mind that it doesn't matter which equation or which variable. However, it is best to solve for the variable that doesn't have a number in front of it. So when I look at my first equation, I have 5x plus y is equal to negative 19, and the y variable doesn't have a number in front of it. Coefficient there is 1, and it's understood that it's 1. We just don't write it. So for step 1, I want to take that equation, 5x plus y is equal to a negative 19, and I want to solve it for y. So I'll subtract 5x from both sides of the equation, and that leaves me with y is equal to negative 5x minus 19. Now for my step 2 says to take the other equation. The other equation is negative 7x plus 3y is equal to 9. I want to take the other equation and replace it with what I found y to be in step 1. Well, in step 1, I found y to be negative 5x minus 19. So when I rewrite that other equation, it becomes negative 7x plus 3. Now remember, when I get to the y value, the y variable, I don't put y, I put negative 5x minus 19. And then I finish the rest of the problem. Equals 9. Now here you'll notice that I have two x variables, so I can solve this. I'll bring down my 7x. I'll use my distributive property. 3 times negative 5 gives me negative 15x. And 3 times negative 19 gives me a negative 57. Bring down my equal, bring down 9. I can combine my like terms here. I have negative 7x minus 15, which will give me a negative 22x minus 57 equals 9. Now here I'm just solving for x. Add 57 to both sides. And this gives me a negative 22x is equal to 66. I'll divide both sides by a negative 22. And that leaves me with x is equal to negative 3. Okay, so now that I know x is equal to negative 3, I'm ready for my step 3. I've solved for x. Now I need to know, well, what's the numerical value for the y? So I'll go back up to step 1. For step 1, I had y is equal to this negative 5x minus 19, and I'll use that equation. That becomes y equals a negative 5x minus 19. Now in step 2, I solve for x, and now that I know x is negative 3, I'll simply substitute that into my step 2. So this becomes y equals a negative 5. Now instead of writing x, now that I know x is equal to negative 3, I'll change it to negative 3 minus 19. All I did was make a substitution. Okay? And I'll solve this for the y value. So this gives me y is equal to negative 5 times negative 3 is a positive 15 minus 19. 15 minus 19 is simply negative 4. So now that I have my x value and my y value, I can put my solution set together. Now once again, remember that the solution is an ordered pair, and in an ordered pair, the x value comes first. So that becomes negative 3 for the x and negative 4 for the y. So my solution is simply negative 3, negative 4. The last example, we have 3x plus 6y equals a negative 24, and 5x plus 2y equals 16. Well, step 1, by now you know, says to solve one of the equations for one of the variables. I've also told you that it's best to solve for a variable that has 1 as a coefficient. In other words, you want to solve for a variable that does not have a number in front of it. In the previous two examples that we did, we were fortunate enough to have that. This time we're not. Each one of our variables has a coefficient other than 1. They all have numbers in front of it. So the next best thing is to pick an equation and solve for a variable and not end up with a fraction. And I'm going to tell you what I'm going to show you what I'm talking about. So for my step 1 for this problem, I'm going to look at the first equation. The first equation is 3x plus 6y equals negative 24. Okay? And I'm going to solve for x. So if I solve for x, that means I'm going to subtract 6y from both sides. That leaves me with 3x is equal to a negative 6y minus 24. Now I'll divide everything by this positive 3. That leaves me with x is equal to negative 2y minus 8. Okay? Now I don't have any fractions. Now I want to show you what would have happened if I would have used this second equation. I don't need you to write this down. I just want you to watch and see what happens. Let's say I had 5x. I'm using the second equation. 5x plus 2y equals 16. And let's say I solve for x in this case. So I'd subtract the 2y from both sides. That leaves me with 5x is equal to a negative 2y plus 16. Now divide everything by 5. That leaves me with x is equal to a negative 2 over 5y plus 16 over 5. Now we could solve that. It'll be a little messier and probably it'll be a little bit more work, but I don't want to have to deal with all of these fractions. And it would have been the same thing if I'd solved for x. I'd end up with a fraction somewhere. So always try to solve for a variable that divides out evenly when you have to do your division. Okay? So now I have my step 1 done. Now I'm ready for step 2. So step 2 says to take the other equation. So now I'm ready to use this 5x plus 2y equals 16. Now in step 1 I said x is equal to this negative 2y minus 8. So I'm going to take this negative 2y minus 8 and I'm going to substitute it in. Going to make that substitution where the x is. So this will become 5 times negative 2y minus 8. Then I'll finish writing the rest of the problem. Plus 2y equals 16. Okay? Now I can solve for y and figure out what my y value is. Do my distributive property. Apply my distributive property. This will give me a negative 10y minus 40. Bring down plus 2y equals 16. Have like terms here that I can combine. So this gives me a negative 8y minus 40 equals 16. Add 40 to both sides. At this point, I'm just simply solving for y. This gives me a negative 8y is equal to 56. Divide both sides by negative 8. This gives me y is equal to negative 7. Okay? Now my step 3, I think I'll do it over here. For step 3, now it says to go back to step 1, take that equation that you had in step 1. I think I want to change that color. It says take that equation that you came up with in step 1 In step 1, remember we came up with x is equal to a negative 2y minus 8. So we're going to use that equation. X equals negative 2y minus 8. Well, now we're going to solve for the x value. Well, now that I know that y is equal to negative 7, I'm going to make that substitution and I'm going to substitute it in where I have the y value here. So this becomes x equals negative 2 times, now that I know y is negative 7, I replace it with a negative 7 minus 8. Well, negative 2 times negative 7 is a positive 14 minus 8. 14 minus 8 will give me 6. So I have x is equal to 6, y is equal to negative 7. So that means that my solution is, remember you have to put the x value first, is 6, the y value negative 7. You make sure that you put it in the correct order. The x has to go first, the y has to go second, because your answer is actually an ordered pair. So once again, my final solution is 6, negative 7.